Lesson 8.1 is essentially going to be a review. First, we're going to be talking about midpoint and distance formulas. Now, whenever we have a line segment, we remember from geometry that we can take its endpoints and strike an arc, or essentially create the circles in between them. And from where those two circles intersect, draw a straight line. And wherever that line hits our line segment, that's our endpoint. So that would be the construction of a midpoint visually. That's our geometric way to do it. We're going to look at how to algebraically formulate where is the midpoint. If we know where the endpoints are, what their coordinates, the numbers are, how can we find the numbers, the coordinates of our midpoint? So, again, if we just look at things kind of visually, if we have our segment, this blue one right here that goes from our endpoints, our first point is x1, y1, all the way to our second point, x2, y2. And we want to find that midpoint, that spot right here in the middle. Well, essentially, we're just taking the average of the 2 points, because the average finds something right in the middle, or the midpoint. So if we're looking at the x component, so we're looking in this direction, our first point comes this far out in x, and our second point comes this far out. So to find our average, we just need to find the exact middle of those, which would be right here. So that would be our midpoint, or our middle x value. Same thing if we're looking at our y values. Our first one only goes this high. Our second one comes up to here. So our middle point for that would be right in here. Follow those out, and our middle points come right to that midpoint. So how do we find what this value for y and this value for x are? Well, again, we're just taking the average. And remember, the average of two numbers, say they're a and b, we would do a plus b over 2. That's how you find your average. So again, to find the average x value, you would just do x1 plus x2 divided by 2, or your average y value would be y1 plus y2 over 2. So you're finding your average x's and your average y's to find the midpoint. So let's see how this works on a specific example. If we were landscaping and we have 2 square flower beds and a sprinkler halfway in between them, and we want to find the coordinates of the sprinkler if the origin is at the lower left-hand corner of the grid. So that would be right here. We'll put a green dot in the middle there so we see exactly where we're going. So that's our point 0, 0. The midpoint of our flower beds would look like that. One is found at 4, 5, and one is found at 14, 13. And we want to find, if this is our segment right here, we need to find where that midpoint is, so that middle piece. And again, remember, we can just use our different components. Our x component down here, find the average, and our y component, find the average. So we're looking for this middle piece. So we need to take 4 plus 14, which is 18, this over here, and divide it by 2. We would get 9. So right here is 9. Same thing, 5 plus 13, and which comes out to 18, divided by 2, because we're looking for the average, and that also comes out to 9. So right here is our 9 as well. And this makes sense because from here to here is 5. 4 plus 5 is 9. 9 plus 5 is 14. So there's the same amount in between them. Same thing here. From 5 to 9 is 4, and 9 to 13 is 4. So there's the same distance in between them. So it cuts that value 9, cuts both of these in half perfectly. So our midpoint is right here at 9, 9. So that was the midpoint formula. Now we're going to look at the distance formula. So if we have any line segment on our coordinate grid that goes from one point, x1, y1, to another point, x2, y2, we can essentially look at that as though it were a right triangle. And this would be our value c. So we could call this a and this b. Remember then, Pythagorean theorem tells us that c squared equals a squared plus b squared. So now all we need to find is our lengths a, this one, and b, this one, and we can find that length C. Well, A should be pretty easy to find because it's just our change in x. Again, our x1 over to our x2. So we would just say A equals x2 minus x1. Same thing, B is just our change in y, our y2 minus our y1. So now we just plug those back into this formula. Again, that's just our classic Pythagorean theorem. So we would say c squared equals A, which we know is x2 minus x1 squared, plus B, which is y2 minus y1 squared. And then to find C alone, we would just take the square root of both sides. And it would look something like this. Now, it's going to come out the same if we use the points backwards. And what I mean by that is if we call this x1, x2, we can do that as long as we change this to y1, y2. So as long as this one and this one match up and this one and this one are the same, it'll give you that same formula. So remember, distance formula, they used D, we used C because we were looking at a right triangle. D is the square root of x2 minus x1 plus y2, or x2 minus x1 squared plus y2 minus y1 squared. So let's see how that one works in practice. If we want to find the distance between -3, 6, which would be right here, and 4, -4, which would be right here. So we're looking for this length right here. Well, again, we can just find that y component and that x component. And that's going to make a right triangle, so we want our C value here. So we just need our change in y and our change in x. Well, that change in x, remember, is just going to be our x2 minus x1. That change in y, I'm going to use red actually, is going to be that y2 minus y1. So we just plug in our numbers. And we would say 4 minus -3. We got that from 4, -3, plus our -4 minus 6 gives us these ones here. So we basically just plug in our values into our formula. Now a little algebra, just solving those through, gives us this 7 squared and -10 squared. This is 7, this is -10. 7 squared is 49, -10 squared is 100. 49 plus 100 comes out to square root of 149. So in the end, we would say the distance in between them, or our C value, is the square root of 149. Now, if this ever comes up on a test, like a multiple choice test, it would say which point is farthest from -1, 3, which again, we can look at that visually. So it would look something like this. So our first choice is A, would be at 2, 4, look something like that. B is at -4, 1, be somewhere like that. C is 0, 5, which would be right here. And D is at 3, -2. So already, just by looking at this visually, we can kind of see some of the points we can tell are a lot closer and some are a lot farther. So we might have an idea already which one we think is the farthest. But we'd have to use the distance formula to solve. So this is the distance to A, this one is our distance to B, this is our distance to C, and this is our distance to D. And at the end, after we plug all those values in and solve them out, distance to A is square root of 10, distance to B is square root of 13, distance to C is square root of 5, and distance to C is the square root of 41. And obviously out of all those, square root of 41 is the largest. So it's the farthest distance away. So we'd say the farthest one from point -3, 1 is D, the 3, -2. And that's how you would solve a question like that.